Welcome to the deep dive. Today, we're really getting into the nitty-gritty of writing Docker files for production apps.
Right.
You want the essential knowledge fast without getting totally lost in the weeds. So think of this as like your shortcut to building containerized apps that are actually robust and secure.
Yeah. The sources we looked at cover a lot from, building the image to running it. Our job here is to pull out the most critical pieces.
Exactly. We want to focus on what really makes a Docker file, well, production ready.
Okay.
So let's jump straight in. Multi-stage builds. What's the core idea there?
It's fundamentally about separation. You have one environment, stage one, let's say, where you build everything, compile code, install dev tools.
Okay.
Then you have a second, much leaner stage that just takes the built application artifact, maybe some runtime dependencies, and nothing else.
So you ditch all the build tools and intermediate stuff.
Precisely. The big win is a drastically smaller final image, just the essentials to run the app.
And why should you really care about that smaller size beyond just, disk space?
Well, two main things. Security. A smaller image has a smaller attack surface. Fewer libraries, fewer potential holes.
Makes sense.
And performance. Smaller images transfer faster, deploy quicker. It adds up.
Right. Okay, so that's multi-stage.
Yeah.
What about the base image itself? What are the, absolute must-dos?
Choose minimal. Think official images like Alpine, or even better, distroless, which contain only your application and its runtime dependencies.
No shells, no package managers.
Exactly. Bare minimum. Also, critically, make sure they're actively maintained. Security updates are key.
And tagging. People often just use latest. Bad idea.
Generally, yes, for production. Ditch latest. Use specific version tags like Alpine 0.3, 0.18, or whatever. It ensures reproducibility. You know exactly what you built on today and 6 months from now.
Good point. Predictability.
Yeah.
Okay, lean base, specific tags. Now, inside the Docker file itself, how do we structure things efficiently?
Docker builds in layers. Each run, copy Y, ADD instruction creates a new layer. So you want to leverage Docker's layer caching. Order your instructions so the things that change least often come first. Your base image, maybe system dependencies.
And stuff that changes all the time, like my application code.
That goes last. That way, when you rebuild, Docker reuses the unchanged layers from the cache, making builds much faster.
Smart. And I hear grouping commands helps too.
Yes. Chain RUN commands together using NR instead of multiple RUN lines. Have one RUN apt-get update and apt-get install -inrf barlib app lists. Fewer layers, smaller image.
Got it. And .docker ignore.
Crucial. It's like .git ignore, but for your Docker build context. Tell Docker to ignore log files, .git directories, local config, anything that doesn't need to be in the image. Keeps the build context small and prevents secrets leaking.
Right, keep it clean. Okay, shifting gears a bit to security within the container, what's vital?
Non-root user. Absolutely fundamental. Add a dedicated user and group and use the USCR instruction to switch to it.
Why is that so important?
Principle of least privilege. If an attacker compromises your application, running as root gives them keys to the kingdom. Running as a limited user contains the damage significantly.
Makes total sense. What else?
Clean up. Remove package manager caches, like apt-get clean or equivalent. Uninstall build tools if they aren't needed at runtime, especially in single-stage builds, though multi-stage handles this better.
And scanning.
Definitely. Integrate vulnerability scanning tools like Trivy, Claire, or Snyk into your build process, or use a registry that scans automatically. Catch known vulnerabilities before they ship.
Okay. And I've heard about read-only file systems.
Yeah, that's a more advanced step, but very effective. If possible, run your container with a read-only root file system, read-only flag. It makes certain kinds of attacks much harder.
Okay, that's hardening the container. What about the application's own dependencies?
Nail them down. Pin exact versions in your requirements.txt, package.json, gem file, whatever you use, and use the corresponding lock file, pipfreeze, package-lock.json, gemfile.lock.
Why exact
Consistency and security. Avoids unexpected breakages from upstream changes, and lets you vet specific versions for known vulnerabilities. It also ties back to reducing image size, only install what you absolutely need.
Right. Minimize everything. How about configuration, like database passwords or API keys?
Environment variables are the standard way. Inject configuration at runtime. Don't bake secrets into the image.
Okay, and making sure the container runs properly.
Define proper health checks. Health check instruction. This tells the orchestrator, like Kubernetes or Swarm, if your application is actually healthy, not just if the process is running. Also, set sensible defaults for any required settings.
Good practices. Now, something maybe a bit newer, image signing and SBOMs. What's that about?
Trust and transparency. Signing images with tools like Cosign or Notary provides cryptographic proof that the image you're running is the one you intended to build and hasn't been tampered with.
Like a digital signature.
Exactly. And SBOM's software bill of materials generated by tools like Sift give you a detailed inventory of everything inside your container image. All the libraries, packages, their versions.
Why is that useful?
For tracking dependencies, identifying licenses, and quickly finding components affected by new vulnerabilities. It's crucial for supply chain security.
So building trust in the whole pipeline. How does this integrate with CI/CD?
Seamlessly, ideally. Automate the Docker build in your CI pipeline. Use the build cache effectively. Push images to a secure registry, preferably one that does automated scanning.
And deployment.
You can use policy enforcement tools like Open Policy Agent, OPA, to ensure only compliant images. Example, scanned, signed, non-root, get deployed. Automation is key here.
Makes sense to lock it all down. Okay, finally, once the container is actually running out there, any last tips?
Resource limits. Always set CPU and memory limits for your containers in the orchestrator. Prevents one container from hogging resources and affecting others.
Crucial for stability.
Yes, and handle signals properly. Your application should catch termination signals, like sigterm, and shut down gracefully. Finishing requests, closing connections.
Logging.
Log to standard output and standard error. Let the container orchestration platform handle log collection, aggregation, and rotation. Don't write to files inside the container unless absolutely necessary.
And just making it understandable for other humans.
Oh, absolutely. Documentation. Use label instructions in your Dockerfile to add metadata maintainer info, links to source code, build arguments, licensing. Explain any assumptions or required startup parameters. Makes life much easier for everyone else.
Okay, wow. That's a lot, but it boils down to some core principles, doesn't it?
It really does. Focus on efficiency, keep images small and builds fast. Focus on security, non-root scanning, minimal components. And focus on reproducibility and transparency, version pinning, signing SBROMs.
So getting these Dockerfile practices right isn't just a technical detail, it's fundamental to a solid deployment strategy.
Precisely. It builds a foundation for more robust, secure, and trustworthy software delivery.
So here's something to think about. As our applications get more complex, maybe with microservices and intricate dependencies, how could really adopting these Dockerfile best practices fundamentally change how you approach deploying and maintaining your software? Maybe check out a tool we mentioned like Trivy for scanning or Cosign for signing, see how it fits.
Yeah, worth exploring.
Thanks for diving deep with us today.